Hey YouTube, welcome back to my channel, Digits ICT Solutions, and today we are going to be building another retro console, but this time we are going to use a PlayStation 1. I've seen other videos where they've done this, and I'm going to try and keep it as original as possible. My plan is to keep the original controller ports, have the reset button act as a soft shutdown, putting it into a low power state, and then this will be hard on, hard off. So I plan to keep the original power supply using a DC to DC buck converter to step the voltage down. That will be replaced with HDMI, and then I'm going to put a USB port here. And the USB port here is going to be for A, loading the ROMs, and B, using a USB to PlayStation adapter. So in effect, will then give you 4 players. So we're going to completely gut this. This is a faulty system. I bought it off eBay for £5. All that was wrong with it is the laser had gone. So technically I could replace the laser, but I thought, actually, I fancy building a retro games console. I've already done the Xbox, as you've probably seen in previous videos. But with the original controller ports, you know, you'll be able to use the original PlayStation 1 and PlayStation 2 controllers, giving you that nostalgia. So yes, sorry I'm not very good at this, but let's take it apart. See if I can do it quicker than my last one that was over 3 hours long. I do apologise for the length. So first, we need to take it apart. Just put them in height and you get screws that don't want to come out. There we go. It was great fun playing these in the... Well, I got my first PlayStation... Well, I got my PlayStation 1 in the year 2000 for my birthday. And the first game I got with it was Tomb Raider 2. Hours of fun playing that. It was a very capable system for its time. As I say, we'll be keeping the original power supply, because there is I think it's a 7.5 volt feed on the bottom 2 pins, and the top 2 pins are the reset switch. So, and then you've got the middle ones which are 3.3 volts. So we'll obviously test that out with a multimeter to make sure we get the polarity correct and everything else. And then we'll use a DC to DC converter to step the voltage down to 5 volts, 3 amps. So yeah, let's continue taking it apart. Laser deck. Controller ports. Don't need the ribbon, but do want to keep the controller ports, but we might have to take them out to do the soldering. Now, the way we're going to achieve the controller ports working is we're going to use a PlayStation 1, PlayStation 2 controller adapter to USB. And then we'll just solder the adapter side to the back of these ports, so effectively these will then work. I've already tested the USB adapter out on my Xbox retro console, and it works perfectly. There, brute force and ignorance. I'm not the best speaker in the world, so you'll have to bear with me if I get my words jumbled up. I don't mean to. I'm sorry I haven't done a video in such a while. I've been just very busy with work and family. But I will try and do better in the future and try and make some more good content for you guys. Well, if I recall correctly, I think this only had 1 meg of video RAM. 1 meg of video RAM. God. The youth of today and adults of today, well, the youth of today wouldn't understand good old classic times like this. And also another good thing about consoles like this and the Nintendo 64 and the Sega Mega Drive was instant load times. None of this, you bought a game, you put it in, you can't play it straight away, you've got a patch to be applied and everything else, especially when they're like sort of 30, 40 gig. I mean, I had a game on the PlayStation 4, I think it was The Last of Us, and I installed it and there was a massive patch. Luckily I've got fibre broadband, but could you imagine having to wait hours before you could play it? It's simple back in the day, you just stuck a game in and off you went. But my favourite games for this was Tomb Raider, Metal Gear Solid. I'm just trying to think what other ones that we had. There was an F1 racing game I seem to remember. I can't remember what it was called. Tekken. Legendary. Now I got the, I think it was either the 2nd or 3rd generation PlayStation 1 because I wanted one that had the I/O port because I plan to stick the Ethernet socket behind here so it can be closed up and not in use. But obviously the later models, they did away with the parallel I/O port because developers had found a way to use SD cards and things like that so you could illegally play games, which you could do with a mod chip as well, but this enabled you to do all sorts of things, so they got rid of that in future models. Let's take the motherboard out. That motherboard is okay, so just... Now, for this, we don't need to do anything this side of the board unless you want to solder your connections on underneath, but just remember, like what I said in my last video, safety first. If this has been recently plugged in, you don't want to be manhandling this part of the board because this is the primary side of the board. So there's 240 volts flowing through here, and then you've got this capacitor here which is rated at 400 volts, 33 microfarads. So that would give you a pretty nasty belt if you was to touch that and it was charged up. So just safety first. That's all I can say. Very, very important. So take this out. And then obviously you need to decide where you're going to mount things. So obviously I'm going to put my HDMI here. So if we look at the back of this, sort of get a rough idea of how we're going to do it. And that practically slots in there quite nicely. So we'll want to put a little spacer under there and hot glue that in. But that will go there perfectly. So it's just a case of which way up we decide to mount it. So that's very important. You need to decide where you're going to mount everything else. Now in my last video the Raspberry Pi. I had it in a case inside, and someone said to me, well, you don't really need it in a case. I said, well, because of the fan and everything else. And they suggested that I just use little studs and mount it on studs. So, I mean, even there's actually quite a good place for it. So that could stand like that. And then if I put studs to hold it, that would be ideal. So I think that's how I'm going to place it. I'm going to put the Pi itself here. The hard reset, which is one of these pins, which I've got to, not the hard reset, the soft reset on the micro switch. I need to just make sure the switch is normally open and not normally closed. But we're going to wire that to the GPIO header, and then we're going to use a Python script so that when you push reset, it will actually shut the Pi down properly. And then obviously that will turn off the power supply. So that's how we're going to do it. Then obviously this is going to be soldered straight onto the back of here. And then port 1. Now with these, because obviously you might want to use Bluetooth controllers and stuff, so I'd advise if you plan on using Bluetooth controllers, because when this is plugged in, even if there's no controllers plugged in here or here, Retropie will still think the controllers are connected. So what you can do, if you want to have the option of the controller ports at the front, but you also want to use your Bluetooth controllers, so you can actually, if you wire a switch in line with this, you can obviously power this down, so your Bluetooth controller becomes player 1. Because at the moment, if you just wire this up, and you've got player 1 and player 2, even with no controllers plugged in, and then you pair up your PlayStation 3 or 4 controller over Bluetooth, it's going to show as player 3 regardless. So by putting this into a switch, you can switch it off, and then you can assign your controller, and then the Bluetooth ones can be player 1, player 2. So it just depends how you want to do it. So I'm going to put that there, I think. So have I got some studs, which are about the same height. And what I'll do is I'll hot glue these little studs into place. So hopefully these screws fit. There's some smaller ones in there. So those screws don't fit. Well, this particular one doesn't. Is there some thinner ones? Ah, yeah, they've got different lengths of screws. Let's just see. There's some different thickness ones. It's funny because when I ordered these, it said these were okay with the Raspberry Pi, and they are not. Let's see if I've got any others. Did I? Oh boy, so they've sent me screws and studs that don't work with this. So I'll have to find some screws. So I'm going to pause the video and I'll come back to you shortly. I'm back, and unfortunately couldn't find any screws, so I've come up with a solution. I'm going to cut this piece out here. In fact, now we're doing this, I'm going to lower it so you can see a bit better. Hope it's still in focus. So I'm going to chop that off. This is only going to be a temporary solution. I will obviously sort this out properly later. But I'm going to use one of the screws from the actual PlayStation. One that held the motherboard in before. Just to hold it in place. So next, I think we'll see where we're going to put the USB. So we need to see how well the USB, so we only need a short cable. I've got some various length ones. Just quite a bit shorter. So I wonder if so what we could do is take this off and take the guts out and push that in from behind. Let's give that a go. I'll pause the video just while I cut this out, and I'll go from there. Right, we are back. And this is what I've decided to do for the Pi. I'm going to use the original screws, and then what I'll do afterwards is I'll put hot glue on the bottom of the threads of the screws, and they will act as my studs. I've also cut those pieces out. I don't know how well you can see that due to the light. Sorry, the light is very poor in here. What I did is I cut the ports off the motherboard, and then took the centers out and then fitted them. So we've got our USB cable as well. So let's get those screwed in. Clean all the stringy stuff off. Oh, and actually before I forget, that's the Ethernet socket as well, so that's all fitted. I've just done that to save time. So if we just take the Pi out a second. And actually I need to take it out because I've got the fan and heatsink assembly. It's a twin fan job. Right. Okay, so this is our HDMI. What you also want to make sure is obviously the lid still goes on afterwards. Lengthwise they're all the same. Now what we want to make sure of, rather should I say, is that the lid goes back on, so we can see how it all looks. Move that out of the way. Doesn't look too bad at all. So that all goes on fine. That's the main thing, that's what you want. Right, so for the fan, I got this off Amazon. It was quite pricey actually. It was $14.99. That's a 2-fan assembly. It comes with the adhesive tape, double-sided. I don't know if that's going to be too thick or not, but I'll have to do some thermal tests and see how we go. Then we've got a heat sink, which is copper for the underneath chip. So if we just peel this off, which is proving to be difficult, that'll teach me. Don't bite your nails. Biting nails is bad. Oh, we got there in the end. So there's the copper heatsink. And then this is supposed to go on here like so. And then we're going to plug that in. Like that. So on GPIO, we got our 5 volts and ground. And then where the ground is on the second row of pins, directly opposite is where we're going to hook the reset switch up to, and then we'll use the bottom for the ground on that, because the ground is obviously used up this side on the fan. It's quite a neat little job, but I don't know how well it'll work, so I've not tried this yet. It did have some good reviews on Amazon, so we'll just see how we go. Now it's a case of figuring out how. I'm going to root things now. So there, that goes in nicely like that. So if we screw that in. And again, we just want to make sure the top, let's get these heights adjusted. Right, just make sure that the lid goes on. Which again, it does fine. Nothing's been obstructed. So that is excellent. We'll plug that into USB port 2. And USB port 1 will be our controller ports. Just try and... Excellent, so that's held in nicely. Next, I think we will do the controller ports. So what we have is this PS1, PS2 to USB adapter, as I said earlier. Now on this particular one, now you want to test this on the computer or whatever first, because on this particular adapter, that is controller port 1 and that is controller port 2. You'd think, see if you look at it that way, that is controller 1, that is controller 2. So we're going to wire controller 1 to the back of controller 1 and controller 2 to the back of controller 2. If you get them the other way round, it will still work, but your player assignment will be messed up. So you're best to just try it out on something first before you start cutting in and soldering away. So we're going to open this little box of tricks. Now I've got a thing now which will actually hold the PCB while I solder to the back, so I should be able to get a close-up of the soldering, or I'll attempt to. Excellent. So actually, we just need to see where we're going to mount this, and I think I'm going to mount that there. So I'll hot glue that in, but first I'll unplug that. Because now I've got to solder on some leads to the back of these. You can always take these off. And basically the pin wiring is the same, so if you just look at it, the pin corresponds exactly the same. So pin 1 to pin 1, pin 2 to pin 2, pin 3 to pin 4. Sorry, pin 1 to pin 1, pin 2 to pin 2, pin 3 to pin 3, and you just follow that all the way through. Now what I have got is some rainbow cables, which have already got female to female. Sorry, no, male to male. So that'll make it easier to solder because you can just hold the leg on that you want. and then over and across. Just make sure that this is long enough for what I want. So we need 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Yeah, so we need 9 of these. Just helps keep it tidy. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, silly me. 1, 2, 3, 4, 5, 6, 7, 8, 9. Excellent. So if you wire these in order, it should be nice and straightforward. So just need to power the soldering iron up. So if we take that out of the way for a moment. See if I can bring you in closer to the action. There you are. So port 1, port 2. Right. Then what we should be able to do is just heat the solder up and pin these in. What we might need to do is add a bit of fresh solder. And my soldering iron is doing something strange at the moment. There we go. Things never go to plan when you do a video. So just get those reflowed. Fact. out of the way. This is moving, so we need to oh, we've got a short, not good. Actually, let's just see if we can get away with sorry if this is poor. That's one. That's one. I think what I'll do is I'll pause the video and show you it once it's all soldered up. I'm sure your soldering skills are better than mine. And I'll show you it once it's done, and then you'll be able to see how you need to wire it, and then you can go from there. Hi, we're back, and this is what you're left with. So you've got your controller ports. They are soldered on to the adapter. Bit tricky, but once got the hang of it, it was alright. I didn't want to video myself soldering, otherwise we could have been here a while. So we are ready to put this back in here and hopefully find a home for it. So goes in like that. Right, so that's back in. Just see where we can mount this. And now that's in, just another test to make sure the lid goes on. I haven't made it too tall. Or just want to see, make sure the lid goes on, because that would be bad if it didn't. And yes, the lid goes on. Excellent. So that's good. That all goes on. No shorts. Lovely. So if we just try and we're still got to find somewhere for the old DC to DC converter to go yet. So just try and tuck that away. Right, so that's what we've got so far. Controller ports all wired up. Pi's in. Now we need to look at the power supply. What I'll be using is a DC to DC converter, which takes, I think it was it takes 35 volts in. No, it doesn't. Yeah, it's 150 volts. I can't remember, but this is the high side. So this will take from 3.3 volts in, I think, to about 30 odd volts. And then this also goes 30 odd volts, I think, so that we can just turn this down to 5 volts. If we unplug this plug, we use for power. In fact, actually, if we got some male to female ones, which would be better for this. Male to female. Or was I dreaming? Yep, got some male to female here. So those top two should be reset. So let's just double check that with the meter. So I've put black and white. And how well you can see this. Black and white. What I've done is I've plugged in male to female end, so we've got the female ends out here. So I want to try and find out which is the reset switch. This for this test. Then we'll switch to female, because obviously two of these will be going on the GPIO header. Let's just find the meter. So we've got continuity there. So if I short those two together, it's weird, it did have oh yes, that would stop it working. See, we should be able to. It's interesting, we're getting a reading. Interesting, so that one's reset then. So that's reset. So in a pin, out a pin, and so if we put that on the top, this one, and go in, This is very strange. That should be long enough, so. We plug that into there. Right. So white and yellow, what does that give us? The reset switch is a bit strange. Let's see what the voltage is on the bottom two pins. So we've hooked up white and black. Now let's give this some power and see. Right. So we've powered the power supply up. I'm going to put the meter onto DC. .60. Just make sure that's right again. Always want to be on the safe side, make sure the polarity is correct. So that means blacks are positive and greys are negative. Drain that old capacitor out, but I want to switch those. Right, there we go. Right, well, I'm going to pause this video now while I solder everything up, and then we'll go from there. Right, that's all soldered up, and we've soldered up the DC to DC converter. Voltage has been tested, so I'll just give you a little demonstration, moving anything that can short out the way. So we've applied power, and as you can see, the Pi is on, the fans are spinning, so that all works nicely. So we'll find a home for that in a second. Next, the micro SD card slot, which is here. So we're going to put this in. Now I was thinking I'd mount it under the lid. So you open the lid, and I'm just going to put it in there, I think. So I just need to see if the lid shuts, which it does. Or whether I put it underneath here, which I might do as well, but just trying to overcome the fans. So do we put that under there? Not as much space in this as there was in the Xbox, but still, nonetheless, got to find somewhere for it. Right, so if we're going to put it in the space, we'll put it in sideways there. So I'm thinking, I don't know if you can see that, I'm trying to put it under there, or I just put it above. And I might just put it there actually. Just see if the lid still closes. Yes, it does. So that is where I'll put it. So we need to put a bit of hot glue on. Very difficult for you guys to see. We take that out of the way for the moment. Right, so I'm thinking I'll just stick it there. Like that. Excellent. So that's going to sit like that. So we need to leave that to dry. then we need to figure out how we're going to, I'm just going to unplug this so we don't end up touching something we shouldn't. Drain the capacitor. Got Ethernet to wire up as yet as well. So I'm thinking which way up does that go in? There we go. So that goes in like that. Actually, I've just realised that's going to mess up the mounts, because that of course wants to go. This will be too high to set up there. Marvellous. Wonder if we can get it in at a... There's literally the only point with the... Trouble is I don't want the fans to get blocked. Just at the moment that's going to go over and block the fan, so we don't want that. Oh, this is a disaster. So wanted that in there somehow. You'd think about repositioning some things. I think you'd have a redesign. Not that I designed it anything in the first place, just sort of shoved it together. Actually, that's going to be good, I think. So if we put that there, that'll give us more room, I hope, in terms of USB. So we've got just cutting it fine there as well. If we take the pie, Yes, if we put that like that there. Yes, that would be a lot better. And that can sit. So yeah, I think that can stand there. That should hopefully keep that out of the way of the fans, which it does. Right, I'm going to pause the video and have a bit of a tidy up with this and go from there. Right, we are back. Now, I did some testing while we was on pause as well, and unfortunately it turns out that there's a problem with this switch. It doesn't seem to work. I've tested the pin outs and I can't be bothered to actually sort of go into sort of more detail, but on yours the top 2 pins should be your reset on the power supply. But yeah, the whole thing is now complete. So let's see if I can give you a better insight into this. And what I'll do is I'll give links in the description to some high quality photographs of the wiring, so you can use that as a guide to wire your own up. And that's it, it's finished. Obviously all that's got to be done now is to be put back together. So make sure if you've covered up any screw holes that you use to screw this back together with, just make sure you don't put screws back in there, because otherwise you'll have problems. So I'm going to take that up because I don't want the fans to get blocked with the ribbon cable. I'll do another video showing it all working. Just make sure nothing's getting crushed. Tuck those out of the way of the fan, that's why I've done that like that, so I don't have this kept completely out of the way of the fan. And you're left with that. Obviously it's got to be screwed back together. And there's the SD card slot. So no, you obviously don't need to see me put it back together screw wise, but I hope you enjoyed the video, and we'll do another one showing it all working. Thank you very much for taking the time. Sorry, I'm not very good at video production. I do make mistakes, but I am only human. I say I just do IT normally, and obviously like to do electronics. But we're not all perfect. But again, I hope you enjoyed the video, and like and subscribe if you want to, and feel free to leave comments down below. Thank you very much for watching.